Which decimal is bigger? 0.36503 or 0.3649? At first glance, these numbers look almost identical. And this is exactly where many students get confused. But in this video, you will learn the simple trick that makes comparing and ordering decimals incredibly easy. And by the end of this video, decimal comparison will feel simple and logical. Comparing means checking which number is bigger, which number is smaller, or whether both numbers are equal. We use special symbols for this: greater than, less than, and equal to. Here are some important rules of comparison. Comparing decimals is almost the same as comparing whole numbers, apart from a major difference, that we do count the number of digits in whole number to decide which number is bigger. But in decimals, having more digits after the decimal point does not automatically make the number bigger. Now, here is the similarity between whole numbers and decimals. In both cases, we compare digit by digit, from left to right. I will explain this in a bit. So, the comparing rules are: always compare decimals from left to right. Start with the whole number. Then compare tenths. Then hundredths. And continue only if needed. Before comparing decimals, let's quickly review whole numbers. 7 is greater than 3, because 7 has a greater value. 98 is smaller than 120, because of more digits. And 40 is equal to 40, because of identical numbers. Comparing decimals works almost the same way. The secret to comparing decimals is understanding the place value. Let's compare these two decimals carefully: 0.36503 and 0.36490. Both have the same whole number. Both have the same tenths. Both have the same hundredths. But in the thousands place, 5 is greater than 4. So, 0.36503 is greater. Let's try another example. Compare 0.7284 and 0.7269. Start from the left. The whole numbers are equal. The tenths are equal. The hundredths are equal. But 8 thousandths is greater than 6 thousandths. So, 0.7284 is greater. Let's see another example with different number of digits, because many students get confused when decimals have different numbers of digits. For example, 0.3649 and 0.36490. Remember, adding zeros at the end of a decimal does not change its value. So, these numbers are exactly equal. Let's understand these extra zeros visually. Think about money. 50 cents, 50.0 cents, and 50.00 cents. All represent the same amount. So, zeros at the end of a decimal do not change the number. Now let's learn how to order decimals. Ordering decimals simply means arranging them from smallest to largest, or largest to smallest. The process is exactly the same as comparing. Compare from left to right carefully. The moment you find different digits, you can stop immediately. Let's solve these numbers step by step. 0.0997 is the smallest. Then comes 0.457. Then 0.48. Then 0.5. Then 0.503. And finally, the largest one is 1.0214. Have you noticed how we followed the same rule to arrange these numbers in order? Here is a very common mistake. Some students think 0.25 is greater than 0.7, because 25 is bigger than 7. But decimals do not work like that. 7 tenths is bigger than 25 hundredths. So, 0.7 is actually greater. Comparing decimals is used everywhere in real life. In money, measurements, shopping, sports scores, and even science. That is why understanding decimal comparison is so important. Let's test your understanding. Pause the video and try solving these comparisons. Let's check the answers. 6 tenths is greater than 2 tenths. 45 hundredths is less than 54 hundredths. And 0.9 is equal to 0.90. Now answer these true or false questions. Pause the video and solve. The first statement is true. The second statement is false, because 8/10 is greater than 8/100. And the third statement is true. Here is your final challenge. Which number is bigger? 0.099 or 0.1? Take your time and comment your answer. Let's quickly recap. Always compare decimals from left to right. Use place value carefully. And remember, extra zeros at the end of a decimal do not change the value. In the next lesson, we will learn how to add and subtract decimals correctly, because this is where many students make careless mistakes. Once you understand the alignment trick behind decimals, these problems become much easier. So, make sure to watch the next lesson in this series. If this lesson helped you, subscribe to Core Concept Academy, where math and science become clear, simple, and logical. And don't forget to follow us on Facebook, Instagram, and TikTok. Thanks for watching. See you in the next lesson.